Hello everyone, my name is Hadi Yornadi from 1IPAB. Today I will present about atomic models. The first we will discuss about the brief history of atomic model. This is a table content. Democritus, John Dalton, G.G. Thomson, Ernest Rutherford, and Niels Bohr. Democritus. Democritus first put forward the atomic theory in ancient Greece. Democritus said that everything can be divided into smaller parts so that one day the parts cannot be divided again. So he called it atom. A means not and Thomas means divide. Atoms come from two words and from A and Thomas. Democritus believed universe made of invisible units called atoms. Democritus named the atoms. Democritus lived in 400 before century. Aristotle said Democritus is a quack. Democritus' atomic theory took 2000 years to prove the right. The weakness of Democritus' atomic model at that time was that the theory could not be scientifically proven. However, this theory is believed to be the basis for the emergence of atomic theory in the next era. This is the example of Democritus' atomic model. It's like a ball. The next one is John Dalton. Dalton's atomic theory states that atoms are like solid spheres and that there are no empty space in them. In addition, Dalton also said that every element has a different atom, but the same element must have the same atom. John Dalton stated that all elements are composed of tiny indivisible particles called atoms. Atoms of the same elements are identical. Atoms for any one element are different from those of any other element. Atoms of different elements combine in simple whole number ratios to form chemical compounds. In chemical reaction, atoms are combined, separate, or rearranged, but never change into atoms of another element. These are the examples of John Dalton atomic model. John Dalton atomic theory. One oxygen atom at 16 mass unit each equal to 16 mass units. Two hydrogen atom at 1 mass unit each equal to 2 mass unit. 16 mass unit add by 2 mass unit equal to 18 mass unit. One water molecule at 18 mass units each. The third one is G.G. Thomson. G.G. Thomson complete name is Joseph John Thomson. G.G. Thomson experiment with cathode ray tubes showed that all atoms contain tiny negatively charged subatomic particle or electron. Thomson's plum pudding model of the atom had negatively charged electron embedded with a positively charged soap. In 1897, J.J. Thomson used a cathode ray tube to deduce the presence of negatively charged particle, named the electron. Example of J.J. Thomson atomic model. These are the example of J.J. Thomson atomic model. These are the spherical cloud of positive charge, and these are the electron. Ernest Rutherford. Ernest Rutherford discovered the nucleus and the positive photons. He surmised atoms are made of mostly empty space, but he didn't know about the neutrons. His famous invention was gold foil experiment, and he stated that the nucleus of an atom is positively charged. In addition, the atomic mass is centered on the atomic nucleus. This is the most famous invention of Ernest Rutherford, gold foil experiment. Particles shoot through the thin sheet of gold. Most shoot went straight through. A small amount were deflected. Hence, the atom must be made of mostly empty space with a small dense nucleus. These are the deflected particles. These are the gold foil, and these are the scattered particles. This the particles without deflection. This the fluorescent screen, and this is the beam of particles. These are the example of Ernest Rutherford atomic model. These are the nucleus, these are the electrons, and these are the orbits. Niels Bohr. Niels Bohr discovered that electron exists in several distinct layers of level. He also discovered the Jimmy neutron model. He discovered that atoms travel around the nucleus like planets travel around the sun. He also discovered the electron's orbit. He discovered that electrons can jump between levels with energy being added or released. He also discovered the orbit of energy level, shells or quanta. These are the Jimmy neutron model. These are the example of Niels Bohr atomic model. These are the electron, these are the shell, and these in the middle are positive charged nucleus, and these are the energy levels. Electron has two conditions. The first condition was ground state, the condition in which the electron is found on the original energy level, and the second condition is excited state, the condition in which the electron receives an extra energy and jumps into another higher level. These are the examples. Ground state, the atom was inside, and excited state, the atom was outside. Sublevel of subshell. A subshell is a subdivision of electron shells separated by electron. Orbital subshells are labeled as P, D, and F. In an electron configuration, the first one, sharp or S, 1 orbital, principal P, 3 orbital, D, diffuse, 5 orbital, and fundamentals F, 7 orbitals. And these are the example of in photos. One box are 1 orbital. Electron configuration. Electron configuration are a simple way of writing down the location of all electrons in an atom. These are the example in photos. These are the example of electron configuration. In oxygen, the electron configuration is 1s squared, 2s squared, 2p4. And the electron configuration for neon is 1s squared, 2s squared, and 2p. The next one is quantum number. Quantum number are a set of numbers which describe every electron that is distributed around the nucleus. Each electron has unique set of quantum numbers. These no electrons have similar set of quantum number. The first one are principal quantum number. Principal quantum number is denoted by n. It's a quantum number which identifies the energy level of the electron being referred to. Examples: 3s1, n equal to 3, 5s2, n equal to 5. Angular movement quantum number. An angular momentum quantum number is denoted by 1. Is a quantum number which corresponds to the sublevel. Examples: S, P, D, F. S is 0, P1, D2, and F3. 3s1 equal to 0 and 2p6 equal to 1. These are the magnetic quantum number. Magnetic quantum number is denoted by ml, refers to the orbital in which electron was formed. Examples: S sublevel 1 orbital, P sublevel 3 orbital, D sublevel 5 orbital, and F sublevel 7 orbital. Spin quantum number. Clockwise is plus 1 over 2, is plus half, and counterclockwise is negative half. These are the examples in photos. These are the examples of quantum number. 334. N equal to 3, L equal to 2, ML equal to negative 2, negative 1, 0, and 1. MS equal to positive half. Answers. The first answer was 3, 2, negative 2, and positive half. And the second answer 3, 2, negative 1, and positive half. The third answer is 3, 2, 0, and positive half. And the fourth answer is 3, 2, 1, and positive half. These are the example in photos. 5 orbital. Thank you everyone for your attention. I'm sorry if I have missed language or something.